Welcome to our video on Armstrong numbers. An Armstrong number is a number that is equal to the sum of its own digits, each raised to the power of the number of digits. For example, 153 is an Armstrong number because 1 cubed plus 5 cubed plus 3 cubed equals 153. Armstrong numbers are named after Michael F. Armstrong, who coined the term. Armstrong numbers are an interesting concept in mathematics and are often used as an exercise in programming courses. Understanding the properties and characteristic of Armstrong numbers can help in developing a better understanding of number theory and programming concepts. Some examples of Armstrong numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 153, 370, 371, 407, etc. These numbers have the property that they are equal to the sum of their own digits, each raised to the power of the number of digits. For example, 153 is an Armstrong number because 1 cubed plus 5 cubed plus 3 cubed equals 153. Similarly, 370 is an Armstrong number because 3 cubed plus 7 cubed plus 0 cubed equals 370. These examples demonstrate the concept of Armstrong numbers and how they can be calculated. Armstrong numbers have some interesting properties and characteristics. 1. They are always positive integers. 2. They are always in base 10. 3. They can be calculated by summing the cubes of their digits. 4. They can have different number of digits, ranging from 1 to infinity. Understanding these properties and characteristics can help in identifying Armstrong numbers and performing related calculations. Now let's dive into the algorithm to check whether a number is an Armstrong number. In this segment, we will explain the steps involved in the algorithm to check whether a number is an Armstrong number. First, we need to understand that an Armstrong number is a number that is equal to the sum of the cubes of its individual digits. To check whether a number is an Armstrong number, we follow these steps. First, we EAK down the number into its individual digits using the modulo operator and the division operator. Then, we calculate the cube of each digit and add it to the sum. Finally, we compare the calculated sum with the original number. If they are equal, then the number is an Armstrong number. Now let's EAK down the process of calculating the sum of the cubes of individual digits. First, we take the number and EAK it down into its individual digits. For example, if the number is 153, the individual digits are 1, 5, and 3. Next, we calculate the cube of each digit. For example, the cube of 1 is 1, the cube of 5 is 125, and the cube of 3 is 27. Finally, we add up the cubes of all the individual digits. In the case of 153, the sum is 1 plus 125 plus 27 equals 153. In this point, we will discuss how the calculated sum is compared to the original number. After calculating the sum of the cubes of the individual digits of a number, we need to compare the calculated sum with the original number. If they are equal, then the number is an Armstrong number. Let's take the example of the number 153. After calculating the sum of the cubes of its individual digits, which is 1 plus 125 plus 27 equals 153, we compare it with the original number, which is also 153. Since the calculated sum is equal to the original number, we can conclude that 153 is an Armstrong number. Let's implement the algorithm in Java to check whether a number is an Armstrong number. To implement the algorithm in Java, the code snippet provided in this slide will help you get started. H2. First, create a new Java class named Armstrong NumberCheck. Inside the main method of this class, prompt the user to enter a number to check if it is an Armstrong number. Store the user input in a variable. Next, convert the input to a string and get the length of the string. This will give you the number of digits in the input. Finally, create a loop to iterate through each digit of the input and perform the necessary calculations. The logic and structure of the provided code snippet can be explained as follows. The code begins by importing the scanner class from the Java util package. It then defines a new class named Armstrong Number Check with a main method as the program's entry point. Inside the main method, a scanner object is created to read user input. Next, a prompt is displayed to the user, asking them to enter a number. When implementing the Armstrong Number Check, there are several additional considerations and optimizations to keep in mind. One consideration is handling invalid user input. The code should include error handling to account for non-numeric input. Another consideration is optimizing the calculation of the sum of the digits. Currently, the code uses the math.pow method for each digit, which can be computationally expensive for large numbers. An optimization could be to use an array to store the powers of each digit, reducing the number of math.pow calls. In this program, we are checking whether a given number is an Armstrong number or not. First, we declare a class called Armstrong Number. Inside the class, we define the main method, which is the entry point of our program. Next, we define the main method, which is where our program starts. Inside the main method, we declare an integer variable called number and assign it a value. The value represents the number we want to check whether it is an Armstrong number or not. After that, we declare another integer variable called original number and assign it the same value as the number variable. We also declare two more integer variables, remainder and result, and assign an initial value of 0 to both of them. Next, we enter a while loop where the condition is original number not equal to 0. Inside the loop, we calculate the remainder of the original number divided by 10 using the modulus operator, %, and assign it to the remainder variable. Inside the loop, we add the cube of the remainder to the result using the math.pow method. Finally, we divide the original number by 10 to remove the last digit from the original number. After the while loop, we check if the result is equal to the number we are checking for Armstrongness. If the condition is true, we print that the number is an Armstrong number. Otherwise, we print that the number is not an Armstrong number. That's it. Our program is complete. We can now test it with different inputs and see the expected outputs. That concludes our video on checking whether a number is an Armstrong number in Java. In this part of the video, the key points discussed are summarized. Armstrong numbers are special numbers that are equal to the sum of their individual digits raised to the power of the number of digits. For example, 153 is an Armstrong number because the sum of 1 raised to the power of 3, 5 raised to the power of 3, and 3 raised to the power of 3 is equal to 153. These numbers are named after Michael F. Armstrong, a mathematician who discovered this property. Armstrong numbers have applications in number theory, cryptography, and computer science. Understanding the algorithm to check whether a number is an Armstrong number is important for programming in Java. This knowledge will enable you to solve problems related to Armstrong numbers effectively. This segment emphasizes the importance and applications of Armstrong numbers. Armstrong numbers have practical uses in various fields such as number theory, cryptography, and computer science. In number theory, these numbers are studied to understand the properties of numbers and their relationships. In cryptography, Armstrong numbers are used to generate secure keys and encryption techniques. In computer science, these numbers are utilized in algorithms and programming to solve problems efficiently. Familiarity with Armstrong numbers and their applications can improve your problem-solving skills and aid in your understanding in these areas. In this part, viewers are encouraged to continue their exploration and experimentation with Armstrong numbers. After gaining an understanding of the concept and applications of Armstrong numbers, it is recommended to implement the algorithm to check whether a given number is an Armstrong number. Practice coding in Java and test the algorithm with different input numbers. Observe the results and analyze the patterns and relationships between Armstrong numbers. By actively exploring and experimenting with Armstrong numbers, you can enhance your understanding and gain practical coding experience.